Right, to answer question B, we need to compare the distribution of height of the year 7 with the distribution of height of year 11. So in doing this, so my year 11, the year 11 will be for, let's just write the medium, that's Q2 by the way, into quarter range, IQR, and the range. So, and this is for year 11 and year 7. Year 11 is 165, and year 7 is 157.5. Interquarter range is 7 for year 11 and 10.5 for year 7. And the range is 20 for year 11 and 24.5. In this case, year 11 seems to be almost all of them are tall. So almost tall, and almost short for year 7. Question 13. So it's always good to read this question carefully. A factory makes 450 pies every day. The pies are chicken pies or steak pies. Each day, Milo takes a sample of 15 pies to check the proportion of the pies in a sample that are chicken is the same as the proportion of the pies made that day that are chicken. On Monday, Milo calculated that he needed exactly 4 chicken pieces in his sample. So, on Monday, he needed 4 chicken pieces in his sample, so that will give us 4 over 15. And overall, he's making X over 450 of chicken pies. So 4 out of the 15 sample will be proportional to the X that we don't know of chicken out of 450. So we need to rearrange this equation and solve for X. Multiply both sides by 450 and also multiply both sides by 15 will give us 4 times 450, or you can cross multiply and then you can see, and that will be equal to 15x, and so therefore x will be equal to 4 times 450 over 15. Well, how many 15 in 45? 1. That'll be 3. 3 times 4 is 12, times 10 is 120. So the X of chicken will be 120. Right, question B. We need to work out the lower bound of the probability that the pie is a steak pie. Well, the question is asking is because on Tuesday the number of steak pie Milo needed in his sample is 6, correct to the nearest whole number. So the clue is in the nearest whole number. So the nearest whole number implies that nearest 1. If he had said nearest 10, nearest 10 number, then that will be nearest 10. But in this case, because it says nearest whole number. That meant one whole number. So what you need to do to that is to divide that 1 by 2. And then our bound will be, which we work on, is 0.5. If it was nearest 10, we will divide it by 10. Then our bound will be 10. So we got 6 now, sample. 6 minus the bound, which is 0.5, and 6 plus the bound, which is 0.5. So the lowest bound will be, so the lower bound will be 5.5, and the higher bound, or highest bound, will be 6.5. Since we've been told to work with the lowest bound, lower bound, so we would write 5.5 over 15 instead of 6 over 15 will be proportional to x over 450. Now, so again, x will become, so in this case, x will become, so I would say 15x will become 450 times 5.5. And but 5.5 is, let's just write it this way. So x, let's just say x will become 450 times 5.5 over 15. And that implies that, well, how many 15 in 45? That's 3. So that would be 30 times 5.5. Right, 30 times 5.5. And 30 times 5.5 will give us, so we could times it by saying, we could do a multiplication by doing 30 times 5.5. So 5 times 0 is 0, 5 times 15 is 15. 5 times 3 is 15. 5 times 0 is 0, 5 times 15 is 15. And if we total that, it will become 0, 5, 6, 1. So that is 165. So the answer is 165. Right, question 14. This is a ratio question, and therefore y plus x colon y minus x is equivalent to k colon 1. What that meant is we need to divide them by each other. So that would be y plus x over y minus x equals k over 1. Cross multiply in this case, which I get y plus x equals k y minus x. And in that case, what do we have is, oh, we can rewrite it because we need to find k. So we need to show that y, actually we just need to show that y equals x into bracket k plus 1 over k. So we need to expand this. So we have y plus x equals ky minus kx. Put all the y's together, right? And then put all the x's together. So I'm going to take the kx to the left and take y from the left to the right. So I'm going to have x plus kx equals y ky minus y. So then I get I get x is a common factor, so I get 1 plus k, or k plus 1 is the same thing, equals y is a common factor, y, k minus 1. So my answer would be y, so I divide both sides by k minus 1. So y would be x into bracket k plus 1 over k minus 1. So that's the answer. Right, we need to turn the recurring decimal into fraction. Okay, so we have x equals 0.436 recurring, and that made it x equals 0.43636, and it goes on. The first thing I like to do is multiply by 1000, because if I multiply by 1000, I then get the recurring. So I will go to 1000 on both sides, multiply by 1000 on both sides, so I get, I move the point, so I get 436.3636. Let's just put 36 there. Okay, I also want to multiply it by 10, so I still get a recurring. So I get 10x equals 4.3636. Right, so I need to take the difference out of these two, so 990x equals 432, because the 3636 will cancel each other out. So, and then I get x equals 432 over 990. If I take out, divide 3 from top and bottom, I will get 144 over 330. If I take another 3 out, I get, well, 3 and 14 is 12, and that's 4, isn't it? So that's 4. I'm left with 2. 3 in 24 is 8, so I get 8. The bottom will be 1, 1, and the denominator will be 1, 1, 0. Now I need to use 2 divided by 2. 2 in 48 will be 24, and 2 in 110 will be 55. No more, it's nothing is divisible anymore, so that's my answer. Question 16. Y is directly proportional to cube root x. Y is directly proportional to cube root x. And that can be written as y equals k cube root x, which can also be written as y equals k x to power 1/3. The reason we were given y and x value is to find k. So to find k, we need to, y is 116, which is 6 times 1 plus 1, 7 over 6, and x is 8. 8 is 2 to the power 3. Now, the reason why I wrote 8 as 2 to the power 3 is because the x to power 1/3, the 3 in 1/3 is telling us to write x in terms of power of 3. So, let's now find k. K is y over x to power 1/3, which is 7 over 6 to power 2 to the power 3 to the power 1/3. And therefore k equals 7/6 2 to the power 3/3, which gives you 7/6 to the power 2, and 2 is over 1, and so I'm going to turn the divide into multiplication, so that will be 7/6 times, I have to flip the other one, the denominator, 1/2, and that gives us 7/12 for k. So k is 7/12. Now we need to find y when k is 7/12. So 7/12 times x to the power 1/3. That's the proper equation now. So I'll put k back into the equation, and then I can now use that equation to find y when x is 64. But remember, the x to the power 1/3, the 3 is telling us to change x to a form of power of 3. So we know that x is 64, therefore x equals 4 to the power of 3. So y is 7/12 times 4 to the power of 3 to the power of 1/3, which is 7/12 times 4, 3 to the power 3, which is 7 times 4/12, and that will give us 7/3, because how many 4 in 4? 1, 4 in 3, in 12, 3. So the answer is y equals 7/3. Number 17. N is an integer. We need to prove that the sum of these functions will always be a square number. Well, 1/2 n times n plus 1 plus 1/2 n plus 1 n plus 2. So what we need to do is just expand this, but take a half out as a common factor. So a half, using square bracket, n times n will be n squared, n times 1 will be n, plus n times n will be n squared, n times 2 will be plus 2n, 1 times n will be plus n, and 1 times 2 will be plus 2. So now I need to just simplify this. So n squared plus n squared is 2n squared. N plus 2n plus n is 4n plus 2. Now 2 is common factor from the square bracket, so I'll be 2/2. I've taken 2 out again this time, not I have to. So that'll be n squared plus 2n plus 1. 2/2 is 1, so I'm getting n squared plus 2n plus 1, which is equal to n plus 1 squared. Because if I expand n plus 1 squared, I get n squared plus 2n plus 1. So therefore, n plus 1 squared is always a square number.